This is my 17/32 drill bit, and so I will be drilling 1/32 under the reamer size. I'd rather be just 1/64, but I didn't have that size drill bit, so this will have to do. This drill bit has a little wobble, and I hope that isn't a problem. This is one that looks like someone turned the shank on it at one time. It's not possibly a factory shank, but I wanted to avoid a taper shank bit because they get so long. So we're going to see what happens. Now watch a little bit of a wobble here, but it should follow the pilot hole. Make sure you got your safety glasses on when you do this. The chips are really flying, and there it went through, and I don't want to hit the vise. The 9/16 reamer is in a collet. Now I slowed the machine down. I put it in back gears, but remember on a Bridgeport you have to run the motor in reverse in back gears. Don't ever run a reamer backwards or you'll ruin it. The finish in my reamed hole isn't quite as good as I had hoped for, but that's kind of typical of what I sometimes get. I'm not sure exactly how sharp these reamers are. They're used and all of that. So this is a piece of 1/2-inch dowel with a slit in it, and I've got some abrasive cloth on there, and let's see what happens. The way I got that wrapped, I need to run it in reverse. So I will do that for a little while and see what kind of results I get. Okay, I spent about 5 minutes on that. That was 100 grit, and I really should go in there with some finer grit as well, but for all intents and purposes that's quite good. And I don't want to do too much of that where I would bell mouth the bore. And I have deburred both ends with this bodacious countersink. I sure do wish I would have had one of these in the right size, but I didn't. Also, if you know what a barrel lap is, this is brass and it's used with lapping compound, but that's a 1/2 inch, so I did not have the right size. 9/16 is kind of a hermaphrodite size, really, but that's what we end up with. And you can see there's plenty of room around here for those little holes that we're going to drill. So that's it for the bore, unless I decide to go back later and improve it just a little bit, but you know, it's not really that critical with a little model like this, as long as you don't have galling in there and deep grooves and scratches, and I do not have that. As I told you before, the entire cylinder here is a little bit too long, so I have laid it out according to this one, and I'm going to saw that off and mill it down to the line, or maybe just mill it sawing would take probably longer than just milling the whole thing off. And the total length now is will be 1.5 inches. Now the reason I like that extra long to start with, let's say I had a little problem when I started to drill or bore or whatever I was going to do, and I had a damaged section, I could then amputate it. That's why I like to start with a little bit longer piece. So I will do this off camera. I found the exact center. You can do that by the crisscross method, or I did it on the surface plate, and center punched it, and I'm going to drill that 1/8 inch. That's for the pivot rod. This will pivot on that. Now on a double acting, I put that exactly in the middle. On the single acting, it was not on center, it was off center. But that's, I guess, up to your design. But as you can see on this one, the single acting, it isn't on the center this way, it's a little bit below. That gives you more swing up here, so a little more room for error there on your ports. So I'm going to drill that 1/8 inch, and this is an extremely important hole, the most important hole of the whole project. I'm going to drill it through both walls and all the way out here, as you can see, and then later on it will be plugged. Now the reason for that is this, that even as careful as you are, quite often you're going to end up with a gap and an air leak right in here. And if that happens, that's your out for putting a temporary rod in there and being able to hold it in the lathe and face this so that it's perfectly perpendicular to that hole and that rod. Extremely important for a good fit. Now it's still going to run if you're a little bit off, but you're going to feel air coming out of there, you know, and it'll just give you a feeling that it's a little bit shoddy. So that's why I'm going all the way through. That's optional. Totally optional, but that's the way I do it. There it is, an 1/8 inch hole. And this brass rod, remember, is going to be held in there with Loctite. I got to cut this off the length. Now, an optional way is you can, this is 1/8 inch, drill that and tap at 540 and thread that in there. But to me, there's a little more room there for error and getting it out of perpendicular. Now again, not only did I drill the 1/8 inch hole through both walls, but then I enlarged this size to 3/16. Again, the reason for that is that a little arbor can be made of 3/16 stock, and I've turned down the end to 1/8 of an inch. And if I run into trouble later on, that will go in from this way, and the little 1/8 inch pilot goes into the other hole. That will be Loctited in there, set for an hour, and then it can be put in the lathe 3-jaw chuck, and ever such a light pass taken on this to get it cleaned up real nice and square, and you'll very quickly then see if one side is machining more than the other, and if you're out of square or out of perpendicularity. But that's one little trick that I really like. And then later on, that hole is plugged. Could be threaded, but I Loctited a 3/16 aluminum in there, and then you sand that and you really don't hardly see it. If you paint it, you really won't see it. And I will have a few burrs on the inside here where I drill those holes that I'll go back and run that lap through there, that emery cloth, real quick, and that'll take that out. Now I may not need this, but I may need it, so we'll see what happens. This is 1/8 inch brazing rod, and I've already threaded that, and that's shown in the other video if you want to go back and look at that. Or what I did is put a 540 die into the die holder. This went into the tailstock, and I threaded that under power. Now that can also be done at the bench vise, but you want that thread to be pretty straight. Now this is too long. I always start with a longer piece, and I will cut it off here on the black line, 1.5 inches long, and then I'm going to go ahead and put it in here with Loctite. And then you say, well, what about if you have to use that arbor method I just spoke of? Well, I will remove that then, and with heat, and it'll come out easily enough. But if you want to thread it in there, you can. Now I'm going to make the little head for the engine. This is 1 inch diameter aluminum, and there were quite a few marks on here because that came from the scrapyard. I just filed that, but it's kind of rough really. But I faced it off, and now using a cutoff tool, I'm going to go in there and make this little step. And I want that to be the diameter of the bore, which was 9/16, so I'm going to feed in and then take some readings on there and take it to 9/16. Take it down to 562. There it is, 562, and let's see if it fits into the hole. Yes, pretty good fit. I mean, it's not where I'm going to have to hammer it in there. Now I'll knock the burr off there. Now the finish here isn't going to be real great with a cutoff tool, but that could certainly be done with a facing tool as well. To me, this was a little faster. Then I'm going to cut it off here so that it's 3/16 thick, and then I'll face it so I have a better finish on that side. Look in the chip pan for it. I want to face this off so there's just enough of a little bit of a lip there to where I can hold it in the 3-jaw chuck, hopefully without it flying out of there. I don't want it too tight to where I put chuck marks on it. This may seem a little crude, but while I still have it in the chuck and I have a real sharp center in the tailstock, I'm just going to gently tap that against the work to find the center, so I have literally a center punch mark right in the center. We'll see how that works. Now watch how I do this. Really, I'm just laying out a bolt circle is what I'm doing. Now the head is resting in the cylinder here just so I got some way to hang on to it. And taking my center finder, I'm going to scribe a line. Do that again. No, it's on there, it's just kind of faint. Now in order to get this perpendicular to the previous line, I will just use the end of the ruler here as a square. I got it squared up now. And I drew a line perpendicular to the other one. I have already punched the center of that on the lathe that I just showed you, but if I hadn't, I know where the center is now, where the two lines intersect one another, and that could be center punched if it wasn't already done. And I'm going to use my little dividers here, and that's set at 3/8 of an inch. It's really handy to have a punched hole in the center to hold that. And I'm going to scribe a circle. Now I will center punch 4 holes, center punch marks, where the circle intersects the crisscross lines. Incidentally, if you guys want to see what's inside of all these toolboxes, and I got 3 or 4 of them, go back and look at some of my videos that are called tubalcain's toolbox toolbox search or whatever, toolbox tour is what it is. And I'm on the little drill press now, and I've center punched the 4 holes, and I'm just going to use a little starter drill there to make sure they stay where I want them to be. All 4 holes have been started now. They don't go all the way through. But notice that I put a little notch on there like Billy the Kid used to put on his gun, or maybe it was Wyatt Earp. And a corresponding notch there, and those could be center punch marks or whatever, so that I know that I don't get the cylinder upside down and I don't rotate this, because it may not be interchangeable. So that's how it will always be assembled. And I think you can see my layout lines a little better now in this close-up, and why I did everything that I did. And there's other ways to do this. And this could be done on a rotary table on the milling machine, just a host of different ways, and there's many different ways to skin a cat. Now what I like to do in a project like this is I'm going to drill a hole. Let's take this one, and I'm going to drill it on the drill press down with the tap drill size for a 440, approximately a 1/4 inch deep or so. Then I will tap that hole. I will drill a clearance hole in the head and put a screw in there to hold it in place, and then I will do the other 3. That way I know that everything will line up and there'll be no surprises later on. I happen to have a whole drawer full of 440 socket head screws, short ones and long ones, so that's what I'm using to hold the head on. And I've already got 1 hole drilled and tapped, and the screw holding the head in place. Now I can drill the other 3 holes, and I know that they're all going to line up. So the first size that I'm drilling, of course, is the tap drill for the 440, about that deep. Then I can take the head off, tap those other 3 holes, deburr them, and then drill the clearance holes in the head. There they are, 4 holes. Boy, they're dangerously close to the bore too. I think if I had to do it over, I would move them out just a little bit. Line up our mark, and we know they're going to fit this way. I mean, it's not, let's see if they'll fit. They're going to fit. I got some burrs in there. I need to blow the holes out. Some burrs and some chips. But there we are, and on that end, and all we got to do now is do the other end. And that'll be just a little bit different, but the holes will be the same. And I'm only going to use 2 screws on the bottom end, just to expedite matters. Spaced out nice. We got our notches lined up here. This I got some burrs in there yet from when I held this in the vise. I'm going to clean that up a little bit. I did some preliminary checks. I blew the chips out of the holes, and now you can see I've got a good fit there with the head. Now I temporarily installed the cylinder and put the spring and a hex nut on there. That's 540. And I'm checking to see how perpendicular my hole was, because I talked about this hole and possibly needing it. Now, here's a piece of paper, and I'm just checking it here as if this was a feeler gauge. I know this is probably 2 or 3 thousandths thick, but it does not go in at any place. So I think it's going to be all right. But also, as I run it the first time, put some bluing on there, and you will see where the wear pattern is, and if it's truly wearing in both places, or all the rubbing is done in another place. So now I will turn my attention to the lower head, if you want to call that, or the packing box, or the stuffing box, or the there's other names for it also. So a lot of that work will be similar to what I'm doing here, or what I have already done here on the. I'm now going to make the packing gland for the or the lower head, whatever you want to call it, and I'll start by center drilling it and reaming it 1/8 inch for that brass rod, the piston rod. Then I'm going to put that step in there like I did on the head, and I'll do that with a cut-off tool and feed it in until I have that little step that's 9/16 in diameter. Show that reaming and drilling operation. You've seen that plenty of times before. I drilled it 7/64 and now I'm reaming it 1/8 of an inch, 1/2 inch deep. You probably could get by with just